In the last class, we have studied about the insertion of node at specific position and the insertion of node at the last of the linked list. In this class, we will study about the deletion, all the deletions, that the deletion at the start, deletion at some specific position, and deletion at the last. So we will start with the deletion at the start. So there are three cases possible while deletion at the last. So when we are talking about the deletion at the start, the three cases are possible. The first case is, let's suppose start is null. Means when your list is empty, then the first case arises. Second case arises when you have a single node in the list. Then what will happen at the time of deletion? And the third case is when you have more than two nodes. You have two nodes or more than two nodes. Then what will happen when you want to delete at start? So in all the three cases, we can check all the three cases. If start is equals to null, in that case, the first case can be checked. If start ka next is equals to null, then second case, else the third case. So what I have done, I am passing the address of start, because since we are deleting the first node, so every time we have to update the address of start, and whenever we have to update the address of start, we are using the call by reference concept. So I'm not sending the content of start, but I'm sending the address of the start here. Since start is already a pointer type variable, because it is occupying the address of, it is storing the address of some node, and I'm sending the address of this start variable as a parameter. So this is 2-time pointer, and this 2-time pointer can be stored in the asterisk type of variable. So let's write the content here. So I have written start. The first case, I have to check whether the list is empty or not. If the list is empty, let's suppose head is equals to null. In that case, we can say print underflow, and we will exit from the program, because I want to delete the first node of the list, but the node itself does not exist, so we will exit from the program. In the second case, I am writing else if pointer of head of next is equals to null. In that case, if this situation arises, then what we'll do, since there is a single node in the list, so we will store the content of this node in some variable. Let's suppose ptr is the variable. So I'm storing the content and the ptr. Then how we will store? So we'll write struct node pointer ptr is equals to pointer head, and after that I am writing free ptr, and after writing free ptr, we are making the content of head as null. Head is equals to null. Means when we are deleting this node, second node, then after deleting the node, the list will become empty. That's why we have to make the content as null. And in last case, else case, else what we have to do, we have to write a variable struct node pointer ptr is equals to pointer head, and what will this do? In the third case, this will point by the ptr, and the content of the second node I have to store in the start. So how this is possible? This is only possible asterisk of head is equals to ptr ka next. How? ptr is this, ptr ka next is, I am talking about the address of this node which is stored in this block. So it will be calculated by ptr ka next. So address of this node will be stored back to start. So what will happen here? Here I have to write like this, asterisk of head is equals to ptr ka next, and after this free ptr. After this we'll write free in bracket ptr. This is the deletion of the node at the start. I have